All right. Hello and welcome, everyone. Thanks for joining us here today. I hope you're all enjoying this year's virtual Hanover show so far. I'm Robert Byer. I'm the product marketing manager at a company named TechSoft 3D. But what I'm really here to do today is to introduce you to my colleague, Jonathan Gerwar, who will be leading our conversation this morning or afternoon, whenever you're joining, or excuse me, wherever you're joining in from today. So Jonathan is a senior manager of technical marketing and overall technical evangelist at TechSoft 3D. He's a 20-year veteran of 3D graphics and CAD and is specifically interested in adopting new technology in manufacturing workflows. He has a background in software development, which brings a unique perspective on building the next generation of 3D software. And with that, I'll go ahead and pass it over to you, Jonathan.
Hey, thank you so much, Robert, and hello everyone. I'm calling in from Oregon, so I'm going to say good morning, but good afternoon to everyone as well. Thanks for that kind introduction, Robert. And I am excited to talk about software toolkits, SDKs, for digital manufacturing. And so this is really going to highlight a number of our different partners and what's going on in the digital manufacturing space when it comes to continuing to push the envelope with technology and being able to leverage all of the data and information that we have in our factories and manufacturing lines. A little bit about TechSoft 3D first. We are driven to fuel innovation, and that's really true, and it's been true over the last 22 years that we've been working as a toolkit provider for developing engineering software. So it could be in the space of robotics or of building and construction or manufacturing or visualization of CAD or 3D publishing. Over 400 different companies trust TechSoft 3D to provide them with technology to build the next generation of engineering software. So anything that's 3D, that's not video games or entertainment, that is a space that we play in. And today, I really want to be talking about digital manufacturing and what we see going on in that space, and some really exciting things that our different partners are doing right now that I think would be interesting to you as well. Before we do that, though, it's going to be important to define what is digital manufacturing in this context of Industry 4.0, the digital revolution, or the digitization of everything around us. And when we think about this digital world, specifically in the space that we work in, we think about the digital representation of, well, we can start with the factory itself. And so there is a representation of the factory. There's a representation of our different pieces of machinery that go into that factory, as well as what we're manufacturing on those machines, or inspecting, or distributing, or moving throughout the factory and that infrastructure. On top of that, we have real-time information associated with each of those pieces. So what's being manufactured when, the quality, the speed, if there's errors in those machines, if we're going to be changing the layout of my factory, all that information, the IoT data, that whole digital twin representation is what we see and view as this digital manufacturing space. And what's really exciting is the information that's being pushed into this context is getting more and more powerful, with more data, and we want to be able to make good decisions around that, from historical data as well as real-time data. So what we're going to talk about briefly today is if we have that digital factory, that digital factory manufacturing information, how can we take that and leverage it to make good decisions around manufacturing and also business decisions. And so we're going to talk about simulating and optimizing our workflows, given that information, and how to do that in the context of the software we're producing, and how people are leveraging what we're calling this component, or SDK, software development toolkits, component technology, to really move their software development forward, and be able to leverage this information. And really three different areas. So first, the flow and process of information of material and the improvement of our processes within our factories and manufacturing. Then we're going to talk about machine control. So if we have all this information, we're able to digest it and use it, how can we control our machines in more intelligent ways? And then also, how do we improve our operations? So throughout this presentation, we're going to see a number of different images. So really, we're bringing together all of the different people that are using TechSoft technology or different technologies that are associated with TechSoft that we either resell or we partner with. So I just want to highlight that most of what you're seeing here are using under the hood either a graphics engine or data access or a modeling toolkit, or a publishing toolkit that TechSoft provides that they embed within their software, that allows them to do these things. So first, we're going to talk about our flow and processes within the factory. How do we lay out our factories in intelligent ways, given this information? So a couple different ways. You see here, using virtual reality, you can lay out the ergonomics of your workspace. So even before we build the different workstations and the different cells within our factory, we can figure out, all right, how does this really work for a person in this space? Am I able to reach my parts and my buckets and move these around in an intelligent way? Also, what we're seeing people do is ask hard questions, really around what if. Even before we build my manufacturing line, what if something changes? What if we change and reroute what the flow of my material? Or what if we add another line? Or what if we don't have the same amount of staff on the floor working at these locations? We can really model out what's going to happen down the road without having to test it in real life. And this is becoming even more important during the last year or so, this global pandemic really changing the way in which our supply chains are operating, as well as staff in my factories. And so we can ask those questions and model it out very intelligently because we have that information available to us. We can also talk about processes when it comes to simulation of what we're going to build and how we're going to build it. And so there's a tremendous amount of work right now going into how can I guess, once I've developed my product, what's going to happen. So here we're seeing heat flow, and how is that working in an optimal way? And can I change the way in which I design my part or my assembly early on in the design process to make sure that the end result is something that I really want, that's going to meet the criteria which it's designed for. And we're seeing this analysis go earlier and earlier in the whole design process, to inform the way in which we're building our parts and our assemblies. The same is true here. Here you see SimCon, they're designing processes around injection molding of plastic and making sure that when we do create that end result, that piece of plastic that comes out of my mold, as it shrinks and warps, what's going to happen to it? Is it still going to fit into my assembly? And it might require us working back in the design process to make sure that when we do create this very expensive mold, that the end result, what it's going to be producing, is going to meet our engineering criteria as well. Another place we're seeing that is in 3D printing. A ton of analysis is going into the 3D printing process to make sure that what we're designing and then building is going to meet, again, the requirements for that particular part or assembly. Well, how about when it comes to machine control? We have a tremendous amount of information available within the CAD systems that are designing these parts and these assemblies. So we're going to show here in a video, this is the Hoops demo viewer. We brought in data, rich data from a CAD part. And it's more than just the surface information that we have available within these CAD systems and within these parts that are saved out, these part files. But it's really a rich ecosystem of a tremendous amount of machining information that allows us to build up that part. So we have first the BREP, or the boundary representation, that allows us to understand the surface information, but embedded in this data, these parts, is rich data around how to manufacture this, like the materials that go into it, the features, so the holes and the hole patterns and the slots, as well as the product manufacturing information, both what we call semantic and visual. So semantic would be something that I can consume here on the right, this threaded hole. Here's all the semantic information that we can automatically parse out from this file and feed to a machine for manufacturing. At the same time, we have visual information in the CAD system, this PMI, that gives us visual cues to make sure that what we're manufacturing is exactly what is coming off the line, and we do that inspection as well. This rich data too can go into very early on in the manufacturing process. We're seeing people leverage that, all the feature information, that PMI for manufacturing to different tolerances. All of that is getting pushed into quoting systems. So if I wanted to, let's say, build this part here, I could push it up to the cloud, have it processed using a set of tools, extract that information from it, and then create an intelligent quote around what would it take to actually build this part from a subtractive CAM approach or from a 3D printing approach. So we see two companies here doing that. On top of that, people are layering a set of artificial intelligence, knowing what's maybe similar parts in the past, what it's taken to build those. And so those are going into these quotes as well, because we have this rich set of data that we can then apply machine learning to as well. Later on in the manufacturing process, that rich set of data that we're able to give access to allows us to do some very intelligent things around the machining process, as well as quality assurance. So here we see Esprit, so that was DP Technology, now owned by Hexagon. They're taking that rich description of the part and putting it into their machines to manufacture them, and making intelligent decisions without having to program the machine, knowing the features that we have to build, trying to get people as close as possible to an end result without having to actually program their vertical millers and their 5-axis machines to build this part. And they're calling that lights out machining. Now, they're not there yet, but because they have this rich data model that they're able to access, they're getting closer and closer. Same thing with the whole quality assurance side of things. So if you have all of the features within your CAD file that you can provide access to within your software, let's say you're building software that is around inspection and quality assurance, you know what you're looking for, and you can automatically program your inspection paths. And then also compare what's coming off. Well, here we have a visual inspection tool from GOM. We can compare that point cloud that we're getting from their visual inspection to the original CAD part, and then correlate it with those features that it's looking for. The last thing is around operations. So how do we really take the CAD data within the context of a mobile device? We see more and more in AR and VR. We're able to load that and provide this correlation between the digital and the real, and provide work instructions. So here, two examples: Diota being able to show an overlay of this CAD data on top of what they're seeing in the real world, and be able to provide real-time information for technicians, for maintenance, for assembly, for troubleshooting. The same Microsoft here on the right. So I guess the one picture that's not a partner of ours right now, but I really wanted to highlight this. They're investing big in AR, and particularly around the space, not of entertainment, but the enterprise space and manufacturing, providing digital assistance tools and troubleshooting remote assist, so that really they can marry both the digital and the real. Here is an example of using some of TechSoft's toolkits to overlay the digital and the real using some of the tools from TechSoft. So here we see two mobile applications. So I have a tablet, this is my living room, a tablet scanning the 3D space and creating a set of a point cloud that registers the location of my tablet in this 3D space. We also have placed a 3D model in that space. And then that's an Android tablet. And then here in iPhone, we do the same thing. We connect to the session ID. So now that I've kind of scanned my space, my virtual space with one, I can do the same thing with the second. So you can see the point cloud that's coming in. And then kind of getting a fingerprint, a digital fingerprint for my area, my space. And now they're correlated together. So I have the same 3D model registered between those two devices, and they're talking to one another. So they're also connected to one another. The CAD data is coming in through a toolkit called Hoops Exchange. So it gives you access to rich CAD data. And then the graphics is being handled by Hoops Visualize. Hoops is a TechSoft set of toolkits used for building engineering applications. And so we can do things like pan, zoom, rotate, and then interact with both the two tablets or the two devices. So just a way, wanted to show you a way in which you can bring the digital into the real world. We're seeing more and more data needing to have that happen. So we have a ton of IoT or IIoT, industrial IoT, being overlaid on top of digital assets. So here's another example of an application that we're building here using this time a web technology called Hoops Communicator. And this is not an application we're selling. This is a demonstration, all right? But we're kind of showing the way in which a factory is bringing data together, both from IoT sensors as well as all the 3D assets. So as we think about digital manufacturing, we are talking about the whole space. We're talking about the building in which this lives in, as well as the machines in that building, and what we're manufacturing as well. So we have a number of different machines here that we brought into our space. So we're kind of looking at an ISO view from the top level, as well as all of our machines there as well. Now we have a list of all the machines. So if I want to, I can kind of go down to a very specific location. It shows me here this welding robot on the line. We're able to embed animations in that. So there's some kinematic information as well. But we can, because we have all of the CAD data, this isn't a game engine, but it's an engineering engine. We have all of the data that allows us to drill down even deeper within the application and get more information around that as well. Not only that, but we can overlay on top of that the IIoT data. And so if there's a piece of machinery that's experiencing historically a problem, and we need to perform maintenance on that, like let's say predictive maintenance on that, we can. Also, we can show, in this case, what happens if something is in a current error state and we need to move to that and provide immediate attention to that as well. So here in this case, we're showing that here are things that we need to show attention to that might be problematic, and we can go in and dig deep into that and troubleshoot that. Because we have the whole CAD assembly, we actually can, for that piece of machinery, we actually can break that apart and drill down not just at the machine level, but down into individual components as well. And the other thing that's really powerful in this particular application is we're bringing data in from multiple different data sources. So in terms of CAD data, the building itself might be from, let's say, an Autodesk product, either Revit or let's say AutoCAD, an AutoCAD file, but the machines might be coming from SolidWorks or Pro Engineer. And then maybe the surfaces of the car bodies there could be coming from CATIA, and we're able to augment all of that together. And then drill down to a very specific point as well here in this particular part, and be able to troubleshoot and replace that. So real briefly, I wanted to talk about the different tools at TechSoft. I mentioned our Hoops SDKs or software development toolkits. We have 4 main ones, and we're really happy to kind of walk you through the nuances of the different SDKs and tools we have available. But all of the different demos today or the applications, many of them are using Hoops Exchange to bring CAD data in, and that's over 30 different file formats we're able to bring into your software application. Hoops Visualize and Hoops Communicator are our 2 graphics engines specifically for engineering graphics for desktop, mobile, and then Hoops Communicator for web. And so you saw a version of both of those. And then for publishing, many times we have to push our data out into a format that's more neutral, like a 3D PDF, a rich 3D PDF, or a 3D HTML, or a 3D printing file format like 3MF, or a standard like STL or JT. Hoops Publish does that. Since we did talk about simulation, I wanted to bring out a number of different toolkits around that as well. So in the last last year or so, TechSoft has invested in simulation software development toolkits, and are now we purchased two companies in this space, and so we have tools for bringing specific data, CAE data or analysis data in, being able to mesh it and visualize it specifically. So when you have CAE data, there's different ways of visualizing that and doing it well. So we both have the VKI tools as well as the Citron tools, 2 huge names out there that many people are using, like Autodesk and Ansys, in this space for visualizing CAE data, specifically simulation data, as well as meshing and solving those problems. And then lastly, we did talk about kind of building and construction. That is important. We're seeing these 2 worlds really collide. So we don't own this Autodesk technology, but we are the only reseller of AutoCAD and Inventor OEM products. So if you wanted to take AutoCAD or Inventor and reskin it with your own name, remove some functionality and add your own functionality on top of it to, let's say, make a layout CAD or a sheet metal bending very specific application, you can do that with these OEM products. So we resell the engine to AutoCAD and to Inventor that allows you to create your own product on top of that. And it's a very quick way to bring your ideas to market, because you're leveraging not just the engine, but also the UI and the workflows that those products have. And then also Real DWG is one of those, another SDK, as well as our IFC readers and writers for DWG data, building and construction data. IFC, same thing in very popular building and construction format in Europe. Those SDKs we also resell. The IFC reader and writer are actually some of our own proprietary technology, but allowing you to get building and construction data into your application. So to wrap up, what we want to do is leverage all of this data to simulate and optimize our flow of material, the processes in our factories, be able to control our machines in an intelligent way, and also augment our operations. We can do that really with rich data translation, and that comes in through toolkits like Hoops Exchange, BDM tools, and Real DWG. You need to have powerful graphics, so that's a key component to 3D SDKs. So that could be Hoops Visualize and Communicator. Those are our mobile, desktop, and cloud visualization toolkits, or the Citron tools for, again, CAE data on desktop and as well on cloud. We want robust modeling tools, so that could be 3D fixing with Polygonica. You saw Esprit CAM solutions. They use Parasolid to power their CAM solution. VDM Mesh and VDM tools for meshing and solving CAE problems. And then AutoCAD OEM and Inventor OEM, they also have their own modeling engines within those that are used throughout the industry. And then lastly, you need a strategic technology partner. And TechSoft 3D would like to be that company. and be that partner in helping you build the next generation of software for digital manufacturing. So if you want to know more, we're happy to do that in the question and answer session. But please also take a look at our website, techsoft3d.com, and we'd be more than happy to connect you with these tools and give you a 90-day evaluation of them. You can sign up for that at techsoft3d.com.